So insertion sort, as far as its time complexity, it's pretty similar overall to the other two we've seen. It's worst case, O of n squared, it's quadratic, because as the length of the array grows, we also have to basically make n squared number of comparisons. But if our data is almost all sorted, so if instead we were looking at something like, I don't know, what would work here? Let's say 1, 2, 3, 4, -1, for example. Well, if we look at 2, we immediately find that it's greater. We don't have to do anything. We stop the loop. Then we move to 3. We find that it's greater than 2. We don't need to keep going. We look at 4. We're good. We look at -1. All right, now we have to go through and put it at the beginning. But compare that to totally random unsorted data where we have to continually place something and iterate, then we're looking at a much worse time. Or actually, what's the worst possible scenario? Something like this, where you start, we get to 3, we have to swap it to here. Then we get to 2, we have to swap it to the beginning. Then we get to 1, and we have to swap it to the beginning again. That's the worst case for insertion sort. But if your data is nearly sorted, you're good. Now, another interesting thing that insertion sort is good at, if your data, there's something called an online algorithm, which is an algorithm that can work as data is coming in, as it receives new data. It doesn't have to have the entire array at once. So for example, let's say that we have some code where people are submitting numbers to us online, live. We're getting them and we want to sort them in. Don't ask why, but let's say we wanted to. With insertion sort, because the way that it works, that we're keeping one side of the array sorted and we're inserting items one at a time, it doesn't matter what the number is that comes in, we can place it where it needs to go. So that's one strength. If you're looking for a sorting algorithm that works in that way, which I probably isn't going to come up, but it is worth knowing that because of how insertion sort works, because we keep one side of it sorted and we insert things in the appropriate place, because of that, it works well in a situation where data is coming in live or streaming and you need to insert it at a moment's notice. Okay, so those are the 3 elementary sorting algorithms. In the next video, we'll just wrap up talking about their time complexity and space complexity, and then also do a quick recap of what we learned.